Now, we will extend this concept to a system called as electric dipole, right? So, this electric dipole is something similar to what you have learned in your chemistry chapter named chemical bonding. There you would have seen no bond moment and all those things. It's something similar. Only thing is we are going to see the mathematical part behind it. So, the heading is going to be electric dipole, right? So here, what I mean by electric dipole is very simple. So here, electric obviously refers to charges, di refers to two, and this pole refers to polarity. So if at all you are able to define a system which has a positive and a negative charge, in the sense the nature of the charges are opposite, but if the magnitude of the charges is same, meaning if the magnitude of the positive charge is q, the magnitude of the negative charge is also going to be q only. If at all we are able to define this kind of a system where these two charges are separated by a very small distance. When I say very small distance, the distance is generally measured in terms of angstrom or nanometer. Angstrom is 10, sorry, angstrom is 10 power minus 10 meter. Nanometer is 10 power minus 9 meter. So generally the distance of separation between the charges will be that small, because whatever things you are discussing here is applicable only on a molecular level. It's on a very small size. Are you able to understand? So generally the distance between the charges is written as 2a, where this distance is very small, right? So consolidating everything, let's give a definition to what this electric dipole is. So what is it? It is a system of what? System of how many charges? Two charges of equal magnitude and opposite nature, right? System of two charges of equal magnitude and opposite nature separated by a very small distance, right? Which are separated by a very small distance. When I say small distance, it is generally in terms of angstrom or nanometer, right? So this is what is called as an electric dipole. This is how you represent it diagrammatically, right? I hope it is clear. Now, first you can listen, then I'll give you time to write. Okay. So the next question is, for this kind of a system, what are all the mathematical parameters that we can define, right? So when I'm talking about this kind of a charge distribution, there should be some significance of it. It is going to have some application somewhere else. So for that, we need to consolidate and collect as much information as possible related to the system. So first is we understood the definition. Okay, if this is going to be the case, then can we define something called as dipole moment for this, which is going to help us in the future, right? So what is dipole moment? If I take the symbol for it as small p, it is basically defined like this. It is the product of, right? It is a product of magnitude of either of the charges, and distance of separation between them. So if you observe, if I am able to look at the magnitude of both, they both are same. So what does the definition say? It says you need to multiply two parameters. What are the two parameters? One is take the magnitude of either of the charges, which is q. You don't take both of them together. No. You take magnitude of either of the charges. Multiply with whom? Multiply with the distance of separation between them, which is going to be 2 into A. So if you are able to write this Q into 2A, then this mathematical parameter is what is called as dipole moment. I hope it is clear. Right? This is given a name dipole moment. There is no derivation as such. There is just a definition. Means I have this kind of a system. Can I define something between them? So if I have to give you a similarity, it is something like momentum also. Like momentum doesn't have a derivation. If you recollect, what does linear momentum say? If an object has a mass, it has a velocity. Multiply them, then you call that parameter as linear momentum. Similarly, you have a system of two charges of equal magnitude. Multiply the charge with the distance of separation between them. You give a name to it called as dipole moment. Instead of writing Q into 2A every time, we write it as P. I hope it is clear, right? Similarly, if I put the next question of what is going to be the SI unit for it, what is answer? So charge is measured in coulomb and distance is measured in meter. One common mistake that people do is if the C is not written in capital, right, it look like centimeter. That is a very common mistake. Without your knowledge, you might do it. So always make sure that you write C in capital. For this one alone, what I would suggest if you can use a hyphen also between them so that you're clear with what you're writing. Are you able to understand? It is coulomb meter, not centimeter. The next question that we are supposed to ask is this physical quantity Q into 2A, which is called as the dipole moment, is it a scalar or a vector quantity? And the answer to that is, it is a vector quantity. So dipole moment is a vector quantity. So when I say it is a vector, it is my job to define the direction as well. So if you see, the dipole moment is always directed from the negative charge towards the positive charge. So this is going to be the direction of dipole moment along the line joining them, right? So P stands for the symbol of dipole moment, cap stands for the direction. Are you able to understand what I'm trying to say? So where is it directed from? It is from the negative to the positive charge. So I can make a note here. It is always directed from negative to the positive charge, right? So now you can make a note of this.